Welcome to Home Learning. Ms. Fakudze taking you for mathematics. Today we're going to be doing trigonometry 2. We already know the trigonometric ratios of angles between 0 to 90 degrees. So today we're going to be looking at the trigonometric ratios of angles from 0 to 360 degrees on all four quadrants of the Cartesian plane. But before we look at that, let's just review angles, the type of angles we know, and the trigonometric ratios of the angles between 0 to 90 degrees, and then we'll move on to all the other angles. Now, type of angles we know, we've heard of the acute angle, obtuse, reflex, the right angle, the straight angle, and the whole revolution. And then we also have angles that add up to 90, we say they are complementary. Then we have angles that add up to 180, we say they are supplementary. Let's put that down and give some examples. We say we have an acute angle, which is an angle that is less than 90 degrees. And then we have the right angle, which is equals to 90 degrees. And then we have the obtuse. The obtuse angle is greater than 90 degrees but less than 180. So we have an angle theta, it's above 90 but less than 180, that's an obtuse angle. And then we have the straight angle, which is equals to 180 degrees. And then we have the reflex, which is greater than 180 degrees. So these are type of angles we know. But for trigonometric ratios, we only know for angles that are less than 90 degrees. So now, we've heard of SOH CAH TOA, the sine, the cosine, and the tangent from a right-angled triangle. If I have a triangle, let's read it this one, triangle A, B, C, and this is a right angle. Let's say angle C is theta. So we know that if this is angle A, then this is side A, we have side B, we have side C. The trigonometric ratios we know is the sine of theta is equals to the opposite over the hypotenuse. The side opposite angle C here is side C. So we have the opposite C over the hypotenuse, which is B. And then we also have the cosine of theta, which should be the adjacent over the hypotenuse. In our case, the adjacent is A over B. And then we have the tangent. The tangent of angle theta, it will be the opposite over the adjacent. So you'd have opposite being C, adjacent being A, which gives us where it's a sine, opposite hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. Now, right angle triangle, we can find a way of calculating the sides and the angles. We can also use Pythagoras. We know Pythagoras says that the longest side of a right angle triangle, the square of the longest side of a right angle triangle is equals to the sum of the square of the other sides. So here we have side B, which is the longest side, which is opposite to the right angle. We know that the longest side of a triangle is always opposite to the biggest angle. In a right angle triangle, The biggest angle is 90 because we know that the sum of interior angles of a triangle is 180 degrees. So if one angle is 90, that's already half of the sum of the angles. That means the other two angles have a sum of 90, which means the other two angles are complementary. So if we have a 90 degrees in a triangle, the longer side will be opposite the 90 degrees. We call that the hypotenuse. And Pythagoras says the length of the hypotenuse squared is equal to the sum of the other lengths squared. In our case, we have b squared, which is our hypotenuse, is equal to a squared plus c squared. So now from this triangle, we can work out examples calculating trigonometric ratios of any right angle triangle. Let's draw our own another one. Let's say this is 60 degrees, and then we are given that this is 12 centimeters. We have A, B, C. We have one angle, we have one side. Which ratio can we use to find the other sides and the other angles? Now here, we have the hypotenuse here. Which of these two ratios uses the hypotenuse? The sine and the cosine, which means we can use the sine, we can use the cosine to find the other sides. We have the angle, so we can start with the sine of 60 degrees is equals to the opposite over the hypotenuse. The opposite here is side BC, and the hypotenuse is side AB. We have the angle 60 degrees. We do not have BC, but we do have AB, which means we can make BC the subject of the formula and find the length of BC. So which means AB is equals to 12. So the length of BC is equals to 12 multiplying the sine of 60 degrees. So now we have side BC. Another ratio that chooses the hypotenuse is the cosine. And the cosine has the adjacent. The adjacent of the angle 90 degrees is the angle 60 degrees is AC. We do not have AC. So which means now we can use the cosine ratio to find the side AC. So we'll say, let me clear this here so we can have some space. Our angle is 60 degrees in our case. Angle A is equals to adjacent over hypotenuse. The adjacent is AC, the hypotenuse is AB. We've been given AB as 12. So this is cosine as adjacent over hypotenuse, adjacent being AC, we don't know. Hypotenuse, we're given hypotenuse being 12. So it's going to be AC over 12. So the length of side AC now is 12 cos is going to be 12 cos 60 degrees. You make AC the subject of the formula. So now we know the simple ratios of the trigonometric ratios of the angles between 0 to 90 degrees. So let's move on and see all the other angles we are talking about in all the other quadrants. Let's start with the 4 quadrants of the Cartesian plane. We say the Cartesian plane has 4 quadrants. So we know the Cartesian plane, we have the x-axis here. We have the y-axis here. So this is the values of x and these are the values of y. And now the signs or the directions of the Cartesian plane. The x-axis is positive this way and negative this side. The y-axis are positive this side and negative this side. So now we're going to look at angles. We say that angles that are drawn anti-clockwise are positive. So we're going to look at the trigonometric ratios of positive angles from 0 here. Our starting point will be the x-axis, back to the x-axis, that is a whole revolution. So our initial arm would be the x-axis, and then we're going to measure the angles clockwise. We're going to get positive angles all the way to the x-axis. So now let's look at the values of x and the values of y in each quadrant. In the first quadrant, these are the values of x here. X is positive and y is positive. We come to the second quadrant. The second quadrant here, and you remember we're speaking of angles here. So from 0, from the x-axis to the y-axis, we see we have a right angle. So we have 0 to 90 degrees. And then from the x-axis to the negative x-axis to the other side, we have a straight angle, which is 180 degrees. This one, the y-axis move along to the negative side, which gives us another 90 degrees from here, which means we have 270 degrees here, and then back to the whole revolution at back to the x-axis, which will give us 360 degrees. So now we're looking at the values of x and the values of y in all these quadrants. The values of x here, the negative. The values of y here are positive. The values of x here, you have them here, are negative, and the values of y here are negative. Then we come here, we have the values of x here are positive, and the values of y, these are the y-axis, we have positive here, we have negative here. So now that we know this, all these quadrants, when we are drawing a right angle, or when we are drawing a triangle here, we start with the right angle triangle because that's what we know. In the first quadrant, this is what I will get. So this is my x value, and this is my y value, and this is my x value. So looking at the trigonometric ratios, how are they going to be for angles in all these quadrants? We're looking at the first quadrant. The value of x is positive, the value of y is positive. And we're going to get the hypotenuse. Then we know that the hypotenuse, we get it from squaring the x value and the y value. So either the x value and the y value is positive or negative, we're going to get a positive hypotenuse. So now we're going to give the hypotenuse r. We say hypotenuse is r. Now let's look at, starting with the first quadrant. The first quadrant, we have the sine formula, the sine ratio. The sine ratio is opposite over the hypotenuse. The opposite here is from here to here, which is y. So which means the sine is y over r. If the sine is y over r, y is positive, r is positive, that means the sine ratio is positive. And now we look at the cosine. The cosine is the adjacent over the hypotenuse. So now we have adjacent, our adjacent here is x over r, which means that x is positive, r is positive, the cosine is positive here. And then we come to the tangent. Tangent is opposite over adjacent. Opposite, our opposite here is y. Our adjacent here is from here to here, so it's the change in x. Y is positive, x is positive, which means all trigonometric ratios in the first quadrant are positive. And now we move to the second quadrant and look at the trigonometric ratios there. We'll start with sine. We say sine, that sine is opposite over hypotenuse. We draw a right angle triangle in the second quadrant. What we have here is the opposite is the y value. We said y is positive, which means we have y over r. R is always positive. So y over r, the sign is positive. And now we look at the cosine. The cosine is adjacent over hypotenuse. Adjacent is x. We say our x is negative, so we have negative x over r, which means the cosine ratios of angles in the second quadrant is negative. We look at the tangent now. Tangent is opposite over adjacent. The opposite here is the change in y. The change in y is positive. And the change in x, which is our adjacent, is negative. So now, trigonometric ratios, from this we get that trigonometric ratios of angles in the second quadrant. The sine is positive, the cosine is negative, the tangent is negative. And then now, we have another right-angled triangle in the third quadrant. We look at the sine. Sine is opposite over hypotenuse. Our r is positive. So now, opposite is the change in y because we're moving from here to here. So the change in y here is negative. So we have negative y over our r, which is positive. This is telling us that the sine ratio is negative. Sine, we move to the cosine. The cosine is adjacent over hypotenuse. The adjacent here is the change in x. The change in x here, our x value is negative, which means we have negative x over r. Our cosine is negative. Our tangent is opposite over adjacent. Opposite here is the change in x, adjacent, opposite is the change in y, and adjacent is the change in x. Our x is negative, our y is negative. So if we have negative x over negative y, what is that telling us about the sign of the tangent in the third quadrant? Now we get that the tangent in the third quadrant is positive, but the cosine and the sine are both negative. Now we look at the fourth quadrant. If I had a right angle triangle in the fourth quadrant, let's look at the cosine. My cosine would be the opposite, it's the adjacent over hypotenuse. This is my angle here, this is the adjacent here, this is the hypotenuse, our r, and this is our opposite. Looking at the cosine, we're looking at the adjacent. The adjacent is our change in x. Change in x here is positive. So we have positive x over r, which means that our cosine is positive. We look at our sine. Sine is opposite over hypotenuse. Opposite here is change in y. Change in y below the x-axis is negative. So we have negative y over r. So the sign here is negative. Tangent. Tangent is opposite over adjacent. In the fourth quadrant, our opposite is the x is the y value here. The y is negative. And then we look at the x is positive. So a negative y over x gives us a negative value. So now we look at the summary of the signs or the trigonometric ratios of angles in all four quadrants. In the first quadrant, which is from 0 to 90 degrees, we have all trigonometric ratios positive. And then we come to the second quadrant. On the third quadrant, between 180 and 270 degrees, we have the sine negative, we have the cosine negative, but we have the tangent positive. On the fourth quadrant, between 270 and 360 degrees, we have sine negative, cosine positive, and tangent negative. So here we have only cosine positive. All the others are negative. So now we can have a summary which says, for the first one, all are positive. For the second one, we have only sine, positive. For the third one, we have only tangent, positive. And then for the last one, we have only cosine, positive. So we have A, S, T, C. All trigonometric ratios are positive for the first quadrant. Second quadrant, only sine is positive. Third quadrant, only tangent is positive. Fourth quadrant, only cosine is positive. So now that we know this, this is going to help us find the trigonometric ratios of all these angles from the first quadrant to the last quadrant. So now that we know we're still using the same trigonometric ratios as the cosine, the sine, and the tangent. But when you're speaking of an angle in the first quadrant, all will be positive. Second quadrant, only sine. Third quadrant, only tan. And fourth quadrant, only cosine. Now we're going to look at the values of those angles in those quadrants. What is the value of the angles, of the trigonometric ratios of the angles in all the other quadrants, now that we know their signs? Now, let's go back to our Cartesian plane again, starting from the first quadrant. Now, if this angle could be reflected on the y-axis to the other side, we will get a congruent angle. So this would be the same. This angle fits to the other angle. So it has the same sides, the equal sides, equal angles, right? So which means the trigonometric ratios of this one here will be the same as those for the other one here, because if I have 45 degrees here, so the tangent will be one the side. The tangent will be one on the other side. So which means we have a corresponding angle for every angle in the first quadrant. We have a corresponding angle in the second quadrant. The same applies on the third quadrant and on the fourth quadrant. Now, this is what we are trying to say here is for an angle in the first quadrant, we have a corresponding angle which they share trigonometric ratios in the second quadrant, in the third quadrant, and in the fourth quadrant. So we have one value of sine for 4 angles in all 4 quadrants. We have one value of tan for 4 angles in all 4 quadrants. In each quadrant, we have the same value in the second quadrant, third quadrant, fourth quadrant. The same applies for cosine. So for a corresponding angle in the first quadrant, you'd have the same value in the second quadrant, in the third quadrant, and in the fourth quadrant. But remember, we just looked at the signs of these trigonometric ratios, which means that I will get the corresponding angle on the other side. But the sign still remains. If it is a tangent on the second quadrant, it is going to be negative. If it is a cosine on the third quadrant, it is going to be negative. But we still have the same value. So now we're going to look at the corresponding values of all these angles. Because what is the angle that corresponds to an angle I have in the first quadrant, in the second quadrant, in the third quadrant, in the fourth quadrant? Coming with the signs of the trigonometric ratios we know from what we've just done here. Because all in first quadrant are positive, sine in the second quadrant, tan in the third quadrant, and cosine in the fourth quadrant. Let's look at this now. We move up to here. So, the corresponding angle, if this is theta, we know that this is 90 degrees, this is 180 degrees, this is 270, this is 360, we start at 0, we come back at the same spot, which is 360 degrees. So now, We have the angle in the first quadrant here. What is the corresponding angle in the second quadrant? If this angle here is theta, what is the size of this obtuse angle from the x-axis? How can we find that? We have 180 here. We know is a straight angle, so we have 180 degrees, and we know the size of this one is equal to the size in the first quadrant, which is theta. So we have 180 degrees minus theta. It will give me the size of the angle corresponding to the angle in my first quadrant. So if I can calculate the trigonometric ratios of the angle in the first quadrant, I can find the trigonometric ratios of the angle in the second quadrant. It is the same, and then I look at the sign. I know that the sign is positive in the second quadrant, the cosine is negative, and the tangent is negative. So if I have the value of the cosine here, I will be able to find the value of the cosine this side. So now, here, if theta is our angle in the first quadrant, what are the trigonometric ratios of our angle here in the second quadrant, which is 180 minus theta? So we'll start with the cosine of theta, the one we know from the first quadrant. We say these two are corresponding, right? So they have the same value of trigonometric ratios, is equals to the cosine of 180 minus theta. But we know that this is the second quadrant. In the second quadrant, we know the signs of the trigonometric ratios. What was the sign of a cosine? The cosine is negative. So the cosine of theta is equals to negative the cosine of 180 minus theta. We look at the tangent. The corresponding angles will have the same values of the tangent. So it will be the same as 180 minus theta. But this is the second quadrant. It means it's going to be negative. So we're going to have it negative. The same applies for sine. We'll have the sine of theta is equals to the sine of theta in the first quadrant. So we have the sine of theta is equals to the sine of 180 minus theta. But we are in the first quadrant is positive sine, the second quadrant is positive sine. So we are all fine. We come to the corresponding angle. Before we move on, let's pick an angle. Let's say theta was 30 degrees. If theta is 30 degrees, what is the corresponding angle in the second quadrant? The corresponding angle in the second quadrant is 180 degrees minus theta. Theta is 30 degrees, which means we have 150 degrees in the second quadrant. As we are moving to the third quadrant, we're looking at the corresponding angles the same way we did here. Here is the angle reflected on the third quadrant. Now we have this angle here, which is the same size as theta from the first quadrant. But we are looking for an angle in the third quadrant measured from the initial arm x. So we're looking for an angle, a reflex angle between 180 degrees and 270 degrees. Those are the range of angles in the third quadrant. So the angle we're looking for is up to here. How are we going to find this angle? When we have a triangle here, which is congruent to the triangle in the first quadrant, whose angle is theta. So what is the angle here for the reflex angle from x all the way to the third quadrant? Let's look at that. Here we have the straight angle, which we know the size of it is 180 degrees. And from 180 degrees from the x-axis, the angle is reflected onto the third quadrant, which means here we have 180 degrees. We're increasing the angle is we're going to 270. So before we get to 270, we cut a theta. So what is the value of the angle from the x-axis all the way to the third quadrant? We have our reference here. It will be 180 degrees. If we are at 180 degrees here, and then we have theta, that means the size of the angle that corresponds to the angle in the first quadrant, in the third quadrant, is 180 plus theta. It is 180 degrees plus theta, because we have the straight angle here, and then we have a congruent angle reflected on the third quadrant. So from 180 degrees going to 270, we do not reach 270, we end at theta, which means the size we have here is theta. Here we have 180, so it's 180 plus theta. So what are the trigonometric ratios of the angles in the third quadrant? We say that we have corresponding angles. If we know the trigonometric ratios of the angle in the first quadrant, we'll have corresponding angles all the way to the fourth quadrant. So now, if we know the trigonometric ratio of the angle in the first quadrant, we know the trigonometric ratios of the angle in the third quadrant. It will have the same value. But we know we looked at the signs of the trigonometric ratios in all this. What did we find in the third quadrant? In the third quadrant, we find that the x value is negative and the y value is negative, which means for the sine, we'll have negative y over r, which will give you a negative sign. For the cosine, we'll have negative x over r, will give you a negative cosine. And then for the tangent, you would have negative x, negative y over negative x. It will give you a positive tangent, which means now the signs of the tangent will be positive, the cosine and the sine will be negative for our trigonometric ratios for the angles in the third quadrant, whereas the value will be the same as the value of the of the angle in the first quadrant, which simply means that sine theta here is equals to the sine of 180 degrees plus theta. But we have a sign. How is the sign in the third quadrant? It is negative. We come to the cosine. The cosine of theta is equals to the cosine of the corresponding angle in the third quadrant. So we have the cosine of 180 plus theta. In the third quadrant, we have negative x, we have negative y, and positive r. So the cosine, the ratio of the cosine here would be negative x over r, which means in the third quadrant, we have negative cosine. And then we have the tangent. The tangent of theta, we know the tangent of theta from the first quadrant. It is equals to the tangent of the angle in the third quadrant, which is 180 plus theta degrees. So these are the trigonometric ratios of angles in the third quadrant. The cosine is positive, the cosine is negative, the sine is negative, and the tangent is positive. Moving on to the fourth quadrant. The same thing happens, the same triangle is reflected on the x-axis. If we have a congruent triangle, which means it has the same sides, it has the same angles, the same sizes of the angles. So if I have the same angle, I have the same trigonometric ratio. So if I have 60, the sine of 60 in the first quadrant would still be the sine of the angle in the fourth quadrant. But an angle in the fourth quadrant is between 270 and 360 degrees. So what is the angle in the fourth quadrant corresponding to an angle in the first quadrant? Let's look starting from the first quadrant. From the first quadrant, the angle is reflected on by the y-axis, which means we have the angle corresponding to theta being 180 minus theta, because we're looking for an angle between 180 and 90 degrees. So it has to be less than 180. It lies on 180, but it has to be less than 180. So for the second quadrant is 180 minus theta. On the third quadrant, we have an angle greater than 180, but less than 270. So now we have 180 plus theta. So now from the first quadrant to the second quadrant and to the third quadrant, we've only used the x-axis. We haven't used the angles on the y-axis. We use the angles on the x-axis, which means we started measuring from 0, so we're going to use 0 for the first angle, and then we had 180 for the second quadrant and the third quadrant. We subtract from 180 or we add to 180. That's how we find the corresponding angles on the second and the third quadrant. Let's look at the fourth quadrant. The angle is reflected on the x-axis. So the angle is lying on the x-axis. This is the angle that is equals to the angle in the first quadrant. So what is the corresponding angle now? The corresponding angle in the fourth quadrant. If I measure an angle all the way here, this is the angle I'm looking for. It is between 270 and 360 degrees. But a triangle congruent to the one in the first quadrant is cut out to get the corresponding angle here. So now, what is the size of the angle in the third quadrant? This is the whole revolution minus this triangle here, which means the angle corresponding to theta in the third quadrant is 360 degrees minus theta. 360 degrees minus theta. The trigonometric value ratios will be the same. We'll have the same value for the cosine, the same value for the sine, and the same value for the tangent. The only difference will be the sine. Which trigonometric ratio is positive in the last quadrant, which is the fourth quadrant? We have positive x-axis, we have negative y-axis. Tangent is opposite over adjacent. The opposite would be the y, which is negative, so tangent is negative. And then we have sine. Sine is opposite over the hypotenuse. Opposite is y, y is negative. And then we have cosine. Cosine is adjacent over hypotenuse. The adjacent lies on the x-axis, which are positive in the fourth quadrant. So we have positive cosine. So here in the first quadrant, we have all positive. On the second quadrant, we have the sine positive. On the third quadrant, we have the cosine, we have the tangent positive. And then on the last quadrant, we have the cosine, the sines of the trigonometric ratios in all four quadrants. And now we're going to look at the corresponding angles. We're going to look at examples of these corresponding angles in all quadrants. We say that in the first quadrant, we have the acute angle, which is theta. So if I have theta in the first quadrant, in the second quadrant, I'm going to have 180 minus theta. In the third quadrant, I'm going to have 180 plus theta. On the fourth quadrant, I'm going to have 360 minus theta degrees. So now, with this, given an angle in the first quadrant, or given the trigonometric ratio of an angle in the first quadrant, when we know this, we have all positive, yes, sine, tangent, and cosine, and then we have the corresponding angles in the first, second, and third quadrant. How are we going to get the trigonometric ratios? Let's look at examples. Now, if they give you, they say that the sine, given that the sine of 30 degrees is 1 over 2. The cosine of 30 is root 3 over 2. And the tangent of 30, so we have 30 degrees here, is equals to root 3 over 3. Find the cosine values of given value. Now, here we are given that our theta, we see that 30 is an angle in the first quadrant. So our theta is 30. Now let's find the corresponding values of 30 in the first quadrant, second quadrant, third quadrant, and fourth quadrant. So we have the first quadrant, we have 30, we have second quadrant, and fourth quadrant. And then we can find the trigonometric ratios. What is the angle in the second quadrant? An angle in the second quadrant is 180 minus theta. 180 minus theta is 150 degrees. So in the second quadrant, the angle corresponding to 30 degrees is 150 degrees. We move to the third quadrant. How do we find the angle in the third quadrant? We say 180 plus theta. Theta is 30 degrees, so our angle in the second quadrant, or the third quadrant, would be 180 plus theta, which is 30 degrees. So what is 180 plus 30? And then on the fourth quadrant, we have 360, the whole revolution, minus the angle theta. Angle theta now is 30, so we're going to have 360 minus 30. And then we go to the questions. They ask you, what is the cosine of 150? 150 is the angle corresponding to 30 in the second quadrant. The cosine of 30 and the cosine of 50 would have the same value. The difference would be in which quadrant it is in. That will tell you the sign of the ratio. Now, the cosine of 30 is root 3 on 2. The cosine of 30 degrees is equals to the cosine of 150 degrees. Where is 150 degrees? Now we have to find where you find 150 degrees in all four quadrants. 150 degrees is in the second quadrant. So if 150 degrees is in the second quadrant, what is the sign of the cosine ratio in the second quadrant? In the first quadrant, we have them all positive. In the second quadrant, we have only sign positive. In the third quadrant, we have only tangent positive. That means in the fourth quadrant, cosine is positive. So if cosine is only positive on the first and last quadrant, the sign of cosine in the second quadrant is negative, which means the cosine of 150 is the negative of the cosine of 30. If the cosine of 30 is root 3 on 2, that means that the cosine of 150 degrees is equals to the negative of root 3 on 2. Now, let's look at another angle corresponding to 30 in the second or the last quadrant. The tangent of 330 degrees. 330 degrees is an angle on the last quadrant corresponding to 30 degrees. We say we find an angle on the last quadrant by subtracting that angle on the first quadrant from 360. If our angle on the first quadrant is 30 degrees, that means that we have 360 minus 30 degrees. That will give us 330 degrees. So now let's calculate the tangent of 330, the corresponding. We say the trigonometric ratios, their values are the same. So if we have one value for 4 angles in all 4 quadrants. So now the tangent of 30 in the first quadrant would be the same as the tangent of 330 in the fourth quadrant, because these are 2 corresponding angles. But now 330 is not in the first quadrant, now it is on the fourth quadrant. We go back and look at the signs of our trigonometric ratios. The signs on our trigonometric ratios in all 4 quadrants. We have the same values, and then it depends on which quadrant it is. First quadrant, all are positive, second, only sine, third, only tangent, fourth, only cosine. We look at 330. Where is 330? 330 is in the fourth quadrant. In the fourth quadrant, only cosine is positive. So if we have an angle in the fourth quadrant, the tangent of that angle would be negative. So what is the tangent of 330 degrees? The tangent of 330 degrees is equals to the tangent of 30 degrees. But now it is negative. The tangent of 30 is root 3 over 3. The tangent of 330 is negative of that value. That means the tangent of 330 is the root 3 over 3 negative. Now let's look at some more examples on finding the trigonometric ratios of angles in the other quadrants other than the first quadrant, because we've been working on angles only on the first quadrant, where we know all are positive, and we know the sine is the opposite of hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. Now that we know that, we know that we have other angles in all four quadrants. And for an angle in the first quadrant, we have a corresponding angle on all other quadrants. So we have a corresponding angle on the second, third, and fourth. That helps us find their trigonometric ratios, because if it corresponds to an angle in the first quadrant, it means they have the same value. So they'll have the same value for any given trigonometric ratio. And on top of that, we know the signs of the trigonometric ratios in each and every quadrant. So this is what we're going to use. If we have angle 60 in the first quadrant, and you're given that the sine of 60 is 1 over 2, the cosine of 60 is equals to root 3 over 2, and then we also have the tangent of 60 being root 3. So now I have the sine, cosine, and tangent of 60 degrees, which means the angle in the first quadrant is 60 degrees. What are the corresponding angles in all other quadrants? Before they even ask you which angle to calculate for, you should be aware how to find the corresponding angles in all other quadrants. So you know in the second quadrant, we say we have 180 minus the 60 degrees. In the third quadrant, we have 180 plus 60 degrees. And in the fourth quadrant, we have 360 minus 60 degrees. And then you have the signs in all four quadrants. So before you answer your question, you know how to find the corresponding angles in all four quadrants, and you know the signs of these trigonometric ratios in all four quadrants. Then they can ask you a question. If you are asked a question, you know you're looking on the quadrant. We start from 0 here all the way on a whole revolution back to 360. So the first quadrant will have an angle between 0 and 90 degrees. A second quadrant will have an angle between 90 and 180 degrees. The third quadrant will have an angle between 90 and 180 and 270 degrees. And the fourth quadrant will have an angle between 270 and 360 degrees. So when you know how the range of each and every quadrant, so given the angle, you will know where to put it without you calculating, going all through this. So once you know where an angle is found and the sign of the trigonometric ratio in that quadrant, it will be easy for you to find it, because they've already given you the ratios of the corresponding angle in the first quadrant. Now let's look what they asked here. They want the sine of 120 degrees. 120 degrees is an angle corresponding to 60 degrees in the first quadrant. And 120 degrees is more than 90 degrees, but it is less than 180 degrees, which means 120 degrees falls on the second quadrant. So if they want the sine of 120 degrees, 120 degrees falls on the second quadrant, the sine of 120 degrees will be the same as the sine of 60 degrees. They'll have the same value. But what about the sine? How is the sine ratio in the second quadrant? We come to our table here. Sine is positive in the second quadrant, which means that the sine of 120 is equals to the sine of 60 degrees. And 120 is in the second quadrant. All sine ratios in the second quadrant are positive. So which means the sine of 120 degrees is equals to 1 over 2 as given. So we have 1 over 2. Another angle is the cosine of 240 degrees. The cosine of 240 degrees. Why is 240? In which quadrant is 240 degrees? We have the first, the second, the third, and the fourth. The second quadrant is 90 to 180. It is not in the second quadrant. The third quadrant is in 180 to 270. So we have 240, which is greater than 180, but less than 270. So now we're working on the third quadrant. On the third quadrant, the value of the cosine, it will be the same as the value of the angle in the first quadrant, which is 60 degrees. So the cosine of 240 degrees is the same as the cosine of 60 degrees. But 240 is not in the first quadrant. 240 is in the third quadrant. How is cosine in the third quadrant? We go back to our table here. Cosine is only positive in the first quadrant and the last quadrant. So in the third quadrant, it means cosine is negative. So the cosine of 240 is the same as the negative of the cosine of 60, which means the cosine of 240 is negative the given value of sine of 240, of the cosine of 240, which was given as root 3 on 2. So the cosine of 240 is root 3 on 2. But on the third quadrant, we say the cosine is negative, which means cosine of 240 is negative root 3 on 2. Another one would be the tangent of 300. The tangent of 300. You do not have to calculate where you find 300 when you know the range of each quadrant. We know the first quadrant 0 to 90, second quadrant 90 to 180, third quadrant 180 to 270, fourth quadrant 270 to 360, which means 300 lies on the last quadrant. So we are looking at an angle in the fourth quadrant, which has the same tangent as the corresponding angle in the first quadrant, which is 60 degrees. So the tangent of 60 degrees you are given is the same tangent of 300 degrees. Now, what is the value? Or how is the sign of the tangent in that given quadrant? In the fourth quadrant, only cosine is positive. So if only cosine is positive on the fourth quadrant, that means the tangent is negative. So if the tan of 60 is positive in the first quadrant, the tan of the corresponding angle in the fourth quadrant would be negative. So the tangent of 300 is equals to the tangent, the negative tangent of 60 degrees. You're given that the tangent of 60 degrees is root 3, which means the tangent of 300 degrees is negative root 3. So what you are doing now is you are identifying the quadrants, all four quadrants, their ranges, where you find the first quadrant, where you find the second quadrant, where you find the third and the fourth quadrant. And then, how is the behavior of the trigonometric ratios in all four quadrants? How is the sign in the first, second, third, and fourth quadrants? And then, given an angle in the first quadrant, how do you find a corresponding angle in all four quadrants? In the first, they will give you an angle in the first quadrant. So in the second quadrant, you will subtract it from 180. In the second, you will add, in the third, you will add it to 180. And in the fourth, you will subtract it from 360. So today we looked at advanced trigonometry, which is the trigonometry of angles on all 4 quadrants. We've been doing trigonometry of angles in the first quadrant using a right-angled triangle. So you know, when you have a right-angled triangle, the angle opposite the right angle is the longest angle of the triangle. We call it the hypotenuse. So we picking an angle, any other angle than the right angle, we can calculate the trigonometric ratios of those using the sine, where the sine is the opposite of a hypotenuse, the cosine being the adjacent line of a hypotenuse, and the tangent being the opposite of a adjacent. So given any size and one angle on any given right angle triangle, you can find the sine, cosine, and tangent. But now we wanted to look at the trigonometric ratios of angles in all 4 quadrants of the Cartesian plane. We say the Cartesian plane is divided into 4. We have 0. We're starting measuring our angle at the x-axis, which is our initial arm. And the right angle, which is the normal, it gives us the first quadrant. The straight angle, it gives us the second quadrant. And the right angle from the straight angle, which is 270 degrees, it caused the third quadrant. And then finally, the whole revolution will give us the fourth quadrant. And then we looked at the values of x and y. In the first quadrant, they are all positive. In the second quadrant, we have positive x, we have positive y and negative x. In the third quadrant, x and y are negative. And in the fourth quadrant, x is positive and y is negative. So using those values, we were able to identify the signs of these trigonometric ratios on all quadrants. As we know that the hypotenuse is r, we find it by squaring the other 2 sides. So either they are negative or positive, we're going to get a hypotenuse which is always positive. What we found there was that all angles in the first quadrant are positive. Second quadrant, only sine is positive. Third quadrant, only tan is positive. And on the fourth quadrant, only cosine is positive. And on the second quadrant, we know that the angle must be between 180 and 90. So if you are given an angle in the first quadrant, you say 180 minus the angle in the first quadrant. In the third quadrant, you say 180 plus the angle in the first quadrant. And in the fourth quadrant, you say 360 minus the angle in the first quadrant. That will give you the corresponding angles, which will have the same trigonometric ratios as the angle in the first quadrant, and the different will be the signs we talked about. That's all we have for today. See you next time. Thank you.